Good evening, fellow physics scholars. Have any of you wondered, does your mass change when you go up an elevator? Well, we got the answer for you. On tonight's episode of Physics with Mr. Howard Scholars, we're going to teach you all about the forces and the change in mass when you're riding up an elevator.
I'm Uniqua. I'm Tasha. And my name's Austin. And we're your backyard friends, the backyard again.
Our hypothesis is that when going up the elevator, weight will increase midway, and then when going down the elevator, weight will decrease.
Good evening. Our journey starts at level 1. According to the scale, the initial mass of our object, myself, read 81.8 kilograms. And our journey for this part of our elevator ride takes us to the middle where we reached a constant velocity. And at that constant velocity, the scale read 84.2 kilograms. Now, we can use F equals mass times acceleration to find the force of gravity acting on our object, me. And so we take the difference of the two and we get a total net force, or the equivalent of the force applied, as 23.25 newtons. And we use force applied, now that we have that, and our mass, and we can solve for acceleration, which is 0.284 meters per second squared.
Look at me being an e-girl.
5 newtons. Now, as we go up into the second part of our journey, we are going from our constant velocity point in the middle, where the scale read 84.2 kilograms, to where our journey ended at the level 2, where the scale went back to 81.8 kilograms. So, again, the same process as before. We used F equals ma and found the difference in force. Now, if you notice, it is just the opposite of our level 1 journey. Right? So, we can use the same equation, F equals ma, and now we can solve for the acceleration, which is just the opposite of what it was before. From the start to the middle of it going.
So next, we go from level 2 down to level 1. Our initial weight for our object Alex is 81.8 kilograms, and once it reaches a constant velocity, it is 78.6 kilograms. Using the equation that we used in the former problems, we can find out that our acceleration is a positive 0.383 meters per second squared. Okay, so now that we have reached a constant velocity, our constant velocity yields us a weight of 78.6 kilograms. Once we reach the final velocity at the bottom, it is 81.8 kilograms again. And from that, when we use the equation, yet again, we find that our acceleration is a negative 3.383 meters per second squared. The opposite of the former. Love you, Mr. Howard.